Hi, good morning, everyone. My name is Sure Park. I'm from Naver Labs Korea. Thanks for the introduction. And today's the talk is about the building called 1784, which is maybe weird as a building name. But yeah, maybe it's better to see the video first. The first robot-friendly building. So take into account that this is promotional video, so it's pretty fancy, and you've seen many robots inside. But I'll talk it later. So the 1784 is the gray colored building in front of the green one. So the green one is the old headquarters. Now they built a new one in front of that, and that's much bigger. And here they put a lot of energy to invest their new technology. So maybe at this point you have a question, what on earth the Naver? So maybe you can call Naver. It's internet giant in South Korea. So we simply say this is Google in South Korean version. And yeah, daily basis, a lot of people log in, and it's kind of a gate for internet service. And of course we have Google, but the market share is much lower than Naver. So its main revenue comes from the advertisement, and they have a lot of money to invest their research and development. Thanks to this business, they not only have a search in this search domain, but also they have many different domains. One of them is also fintech, commerce, and content. And of course, they have clouds for their own, and also they provide cloud services as like Amazon. So, where does this name 1784 come from? Simply because that's their address. So when you look at the address, the number ends with 178 minus 4. And I think one of the high profile thought that's a cool name, so they just took the number, and then coincidentally it was the year beginning of the Industrial Revolution. So they made a story like, okay, we revolutionized new era of the new technology, so we call 1784. Cool name. And this is the pictures, sneak peek of the building, nicely designed, good architecture. And this year they opened, so it's quite a new building. Nice interior. And this is the level we work. So this is office level and meeting rooms, and every cells are deployed here. And robot comes together. Canteens. And if you visit this building, you can take a Starbucks as well. It's located in second floor. And you can, of course, order your cafe latte here, but you can also order through the mobile app. Then maybe you can get it on your place, on your seats. So those robots on the left side, they go to this spot, the blue circled one, and they picked up the cafe and deliver to right on your seat. The other place is for the food delivery service. So they are just queuing up and ready for the service. And once they get an order, and they go through the pathway, and then they pick up the food and deliver to your level. The other location is for package delivery. So every time you see those 5 robots ready to pick up your parcel, and once they get order, then they have those packages inside, and then close the door, and then start their journey. and they end up here in the office level. So on the right-hand side, maybe you see those text robot port. So that's a special equipment in this building, which is completely dedicated for robot movement, vertical movement. So no one is allowed to enter. Otherwise, you get very loud warning signals because that's very dangerous. And they come out from the robot pod, and either they go directly to your seat, or they stop here in the station. Either you charge it, I mean the robot can charge up themselves, or they unload their deliveries. So this is very large scale of the test bed, and Naver Labs invested their whole technology integrated to this building. So it's not only about the robots, as you saw in the video, they have autonomous vehicle, or they have some building management system as well. Of course, the highlight is the robot. So we introduced some delivery services. And the other item maybe is a face sign, so-called. So we don't really carry around this plastic card to enter the room or to open the gate. In front of the door, you just show your face and then they open. It's freaking, yeah, but it works. And also smart building, so you can control your temperature, you can change the blind angles, and of course, the building itself tells you where you park your car, so when you go back home, you don't need to worry about where you parked. Previous company, I spent 10, 20 minutes to find out my car. Now it doesn't really necessary. It's tricky, but it works. It works. And the delivery service works like here. Blind angles, of course, building itself. This is parcel delivery service center, and here it starts. And every movement is being monitored. This is vertical movement of robot port. It's supposed to go all the way to your seat, but in this video, it's only stops here. And also, you can order your coffee, and it's picked up at the Starbucks. It takes around 8 to 9 minutes from starting point to your seat, in average. And finally, you can order your food at lunchtime so that you can keep continuing your walk without leaving your seat. And it goes to the station where you can pick your food and you share it with your friends, your colleagues. In the monitoring room, there are some people who monitors. The funny thing about this food delivery system is it's being loved by high profiles who's super busy when they have lunchtime, so they don't have any time to come down to the canteen. So they keep ordering through this robot system, and they have their lunch on their desk. That's very bad, but yeah, that's the people who order this food delivery. So let's move on to the HRI part. So what are the elements here in this 1784? There's another video. You can follow some subtitles. The robot can also use a human elevator, not only the robot pod. So there can be many different elements when it comes to HRI, but here in this presentation, maybe I'll talk over those 5 elements. So first, the local navigation, which means that beside this global path, when robot encounter person, they have to decide where to move locally without having any order from the top. So this was experiment done much prior to its opening of 1784, so it's already 2 years ago. And in this time, we were preparing other exhibition with the robot. And then we had a question like, okay, when robot encounter person, which direction would be preferred by human? So we conducted some experiments. For example, in a corridor, either you go to right-hand side or left-hand side, but social norm is, of course, the right-hand side. So this kind of rule was applied to the robot. So it always follows the wall, and it always try to walk on the right-hand side so that you don't have any like conflict. And also, as mentioned in the video, the robot needs to avoid, needs to yield kind of personal space so that people don't really have feeling that uncomfortable. So we try to make optimization for its movement. Of course, there is a limitation, so sometimes it doesn't work. And global path. For the services, we have to design where the robot needs to go and where the people needs to follow. And before we before we experiment these services, we didn't really have robots. So in this time, we had to experiment everything using human, not the robot. But it was very fun, and it was really realistic to understand how this service goes. And using this kind of body storming, so to say, we were able to design the packet delivery, the parcel delivery system. So it looks quite similar to what we've done using human body. So they comes around and they know how to avoid collision, and it looks a bit chaotic, but still they have rules how to move around in this system. So eventually we can apply these rules and design a path for the system. And every services like parcel at the packet delivery system has its own, and the food delivery and coffee delivery, they have their own global path. And also the product design was considered as one of the interaction design because it has to do with your interaction with the robot. Of course, it should be looking very nice, cool, but the dimension was really considered as a big part of this design. So roughly, this robot comes to your waist level, and it's considered the human scale of Korean standard. And also, we took a reference that the robot height only goes up to your eye level when you sit down. Because if it goes over your eye level, especially when you sit, it can be feeling very aggressive. So we try to lower down the height of the robot. And also, of course, we tried many physical movements using this robot mock-ups. So when it comes to parcel delivery, maybe we have to test out how much angle you should lean forward and back, and how much of power you need to put, and which level of compartment needs to be located, and so on. So those were all experimented. And the other element on this product design was called back display. Of course, it's located on the back, and it's kind of hidden. So when it's out of service, it doesn't show anything. But when it's on its duty, it shows what kind of task they have. So for example, if they deliver coffee, and you can see the coffee logo behind it, and if it is delivering food, then you can see some food logo. And also additionally, we can show how long you should wait. I mean, how long the robot waits for you, or which floor the robot intends to go, and which direction the robot will take, left or right, something like that. Of course, in the time we didn't really have a robot, we had to test it using paper mockup. And one of the key elements in this design was the gaze, the eye face. So on the market, there are many different eye designs, the facial designs, and some are very realistic, and some are very abstract. And most of them are following this eyeball shape, so it's very circular design. And we tried not to follow this kind of design theme, because once you make it super realistic, and it's really easy to fall into uncanny valley. So we tried not to follow this trap. So that's the result, how we designed this eye movement. So we try not to make eyeball, but at least you can see this is kind of gaze directing toward such a direction. And as you notice slightly here, the eye movement is based on the sphere, not the 2D surface. Because by having this kind of spherical movement, we can give very precise direction of gaze so that people understand which direction of the eye gaze is facing. And it's applied to kind of a turn signal here. So when robot encounters you, then they show which direction they want to go, and you can understand which direction you have to move around. And of course, this eye gaze is used for expressing your emotion. So yeah, joyfulness, surprise, and something else. And it's kind of example you can see in Wild. When they arrived, they show some affiliation to the customer, and they start serving their food or coffee. And the interaction design was also a big part of this whole journey. And yeah, when it comes to robot interaction, you can think of many points. And from the very low level of fidelity, we revolutionized our versions. So in the beginning, we didn't really have a robot, so we had to make a mock-up using the foam board and some tablets or iPads, and also tangled with some Arduinos and cables, which is super dirty, but okay, it was working. And then later on, we put some printed part on top of it so that we can feel how physically it feels. And finally, before we launch our services, we already use production-ready version so that it really works in the system. But when it comes to interaction, it doesn't necessarily mean that robot and human interaction only, because to operate whole system, you have to consider many different points where people chip in this system. For example, this is the measurement tool. So before you load your package, you have to measure if it really fits into the robot. This is not specifically robot-human interaction, but it needs to be done to operate the system. And of course, the customer interface needs to be done too, because you need to use this service, then at least you have to have interface to give order or give submissions. And on the right-hand side, this is one example. In the beginning, we didn't provide this real-time view of robot movement. And many people complain that, robot comes so late, it's slow. And as soon as we provide this real-time view, there's no complaint anymore because they can see where the robots are. And of course, we need some monitoring system too, so we can monitor all the robots deployed in the building. Daily basis, we have slight change in terms of number, but roughly up to 70 to 80 robots are running in operation. And around 20 were used for package delivery, and around 20 or 25 were for food delivery, and rest of them are used for cafe. And also we keep observing our services, and this is a big part of the improvement. So before we launch our service, of course we did some beta testing, and then we could find some problems before we actually go into the service. For example, the first one on the left, the robot arrived technically, but it wasn't really close enough to the customer. So customer didn't really understand if it arrived or not. So he spent a couple of minutes more, and then finally he found a message on his phone that, okay, robot has arrived. And secondly, the picture in the middle shows that the customer didn't really understand the procedure was done, because in UI, in the screen, the robot didn't really tell that procedure is done. So it didn't really say, okay, I'm done, I'm leaving. So they were just standing like this, what should I do more? So we gave a little bit more interaction at the end of the service. So now people understand that, okay, this is end of the journey, end of the service, so I leave. And of course, the local navigation, some movement needs to be refined. Otherwise, you feel very, surprised. And when it comes to monitoring and the observation, we also monitor the service provider as well. So it's not only interaction with customers, but also you have to consider the service provider too. For example, in this food delivery system, the kitchen needs to pack those foods in a very short time. Daily basis, they provide more than 100 packages, the food. And if you spend a couple of seconds more in this part, then you lose your money. So that's why we try to minimize the procedure. And also, in the moment where people take out their orders, people try to, for example, capture the video and take a shot, but it's only in the beginning. So soon after they get used to this system, they don't take any video or any pictures. And maybe you've noticed that we use the face sign system, so you don't really touch the screen, you just show your face and then it opens up, which was preferred in the COVID era. Many people talked about hygiene and being less contact to the robot, but now people complaining more about exposing your face, because that's just taking more time. So this is end of the documentation, and thank you for listening.